Here we go. The solution for this problem is to start here inside the parentheses and do 3 times 2 to get a 6. And then 8 minus 6 is going to give you 2, which you square to get a 4, and then multiply by this 4 to get a 16. This, of course, is 9. Answer should have been 25. Try this one. Almost everybody had this one. The answer should have been 38. Last one. Answer on this one should be 26. Pick a number from 1 to 5. The winning number today is 5. All right, bring it up, and this is worth 100. So we have 19 people here, and we have 6 of them turned in. So 6 divided by 19 puts us at 32% today. For those of you not finished with it, you can work on it now while everybody else is going through the stuff. But you don't get points for the right answers if you're turning it in late, because they're going to be on the screen. We will go through the answers only first. If you need to see the work later on, we'll do that at the end. Number 1 is 33. 2 is 27.5. 3 is 122. 4 is 13. 5 is 45. 6 is 13. 7 is 84. 8 is 14. 9 is 29. 10 is 108. 11 is 9. 12 is 13. 13 is 19.5. 14 is 5. 15 is negative 17. 16 is negative 12. 17 is negative 12. 18 is 65. 19 is 287. 20 is 56. Next up is the test review. Number 1 is 5 hours, 31 minutes. 2 is 71 feet. 3 is 2 hours, 18 minutes. 4 is 6 feet, 2 inches. 5 is 2 feet, 5 inches. 6 is 102 feet, 2 inches. 7 is 2 hours, 57 minutes. 8 is 5 feet, 6 inches. 9 is 3 feet, 5 inches. 10 is 4 hours, 46 minutes. Extra credit A is 27. B is 34. C is 22. D is 104. E is 24. Today's objective. Same as last week, except we have to work on this part down here. Choose and interpret the scale and origin in graphs and data displays. And today's knowledge targets. Choose appropriate units to represent a problem when using formulas or graphing. Here's an example. This is a bar graph, and it's on a coordinate plane. You have to remember that X runs left and right, Y runs up and down. Each one of these little boxes in here, like this, each one of those grids is 1 unit. Or you could make it a different scale if you want to. Instead of 1, 2, 3, 4, 5, and so on, you could determine that you want to make it 10, 20, 30, 40, and so on, depending on the data that you have to show. If you want to show some data where all of the numbers are less than 10, then chances are you'd want all these to be 1, 2, 3, 4, 5, 6, and so on. You wouldn't want it 40, 30, 20, 10 because all of your data would be crammed down into here and it wouldn't show you much. So you can play with the scale on these things in order to make it look the way you want to. So George is making a bar graph to show the distances from his hometown to 5 other cities in the area. The distances range from 5 miles to 25 miles. What should each unit on the bar graph represent in terms of the y-axis? And it's one of these choices through here. Stickler.
C.
Stickler says C. So think of a bar graph like this, poorly drawn one, that's kind of slanted. But here are your hash marks for it going up. And the miles are from 5 to 25. So if I went by ones like this, I'd have to keep on writing 25 more numbers in order to include everything in the graph. So 20 miles wouldn't make much sense because almost everything would be below that. Kilometers is in the wrong unit to begin with. And 10 feet, can you imagine how many marks you'd have to put on a graph of 10 feet for items that were 25 miles? That's too much. So the right answer is indeed C. He is right. George is making another bar graph, and this time it's to show the distances from his hometown to 5 other cities in the area. The distances range from 30 miles to 240 miles. So what should be the unit markings on the y-axis to be able to accurately display this graph? Would we make them go by 1,000 feet at a time, 1 mile at a time, 5 kilometers, or 30 miles? Stickler. D as in dog. Alright, so if we did it in terms of 1,000, there's 5,280 feet in a mile. So you'd have at least 5 hash marks per mile. And there's 240 miles on there, so you're over 1,000 hash marks you'd have to draw for your graph. That's ridiculous. 1 mile, you'd have 240 marks to make. That's still too much. This is in the wrong units, so indeed it would be 30 miles because you would progress by 30 and then 60, 90, 120, and you would end up having to make a total of 8 different marks. So that would be much more reasonable. Here's example 2. Did you have slope, rise over run in junior high? Okay, for those that may have forgot, here's a quick review, then we'll go to the next problem. Slope is rise over run. Remember that the run is the x-axis, and then the rise is the y-axis. So here's the line. The line is going up this way, and its rise is here. You would measure that on the y-axis. Here's the run. Measure that on the x-axis. If slope is 10, then it's really 10 over 1. Anytime you have an integer that is a slope, you have to put it over 1. So in that case, the rise is 10, and the run is just over to the right 1. So slope is 10. Here is the rise over run, and don't forget the 10 would be on the y-axis, and the 1 would be the y or the x-axis. And here's another visualization. There's a slope of 5. It has a run this way of 1 and a rise of 5. Now, given a line with a slope of 150, what would be the ideal intervals in the coordinate plane for both the x and y axes? In other words, how many units per gradation, which is just how it rises or lowers, should there be for both the x and y axes to see the line as best as possible? So here's a coordinate plane. Drew this one a little better. So you have your x-axis markings there, and then your y-axis markings. So 150 for this line, the slope of 150 is so steep that if we started it here, it's going to look like it's almost going straight up. So the slope is 150 over 1. Remember, this is your y numbers, this is your x. You have 4 choices down there for how to separate your grid and how to mark it off for your hash marks. Now to show 150 on the y-axis, how should we separate that off? And notice in your choices you have these items to choose from for y. Would it be smart to use 1? Should we use 1 hash mark per 1 unit and draw 150 of them? No, so let's take that out. I did the same thing in the other class too. I marked off the wrong one and I can't erase it while I'm recording, but I didn't mean to mark that one off. You would be taking this one off, and I'll do it in black right here, there, like that. So those are gone. The other 2 are still in play. Would I use 10 markings, so which means I would have 15 of them for 150, or would I use 50, which means I would have 3 markings, 50, 100, 150. Which do you think is the better choice? He says C for 50. So on my graph, if I only went up 50, 100, and 150, then all of this would be contained just in this area here. It would be crammed down in there. For a slope that large, though, that's going up, it'd be kind of hard to see any movement from side to side because it will slant a little bit. But if you contain everything down in here, you don't get the full picture. So in this case, it would be wise to use 10. Separate it by 10 and go up 15 markings. That way you could get a better picture of it. You don't want your picture too small. You don't want it too large. 150 markings would be too large. 3 of them would be probably too small. So 10 would be the best choice on this. So the answer is A. Alright, given a line with a slope of 300, how should we mark that off on the coordinate plane in order to make our units? Stickler.
B.
Stickler says B, 1 for X and 25 for Y. So notice that the other choices were 1 for Y there and there. That'd be 300 markings. So we can definitely eliminate that. But if we use 100 for Y, that's really not enough. 25 would be a good marking to use on that. And that means you would have 12 different markings. 25 into 30, 12 times. So the answer is B. Practice number 1. In this bar graph, you're going to have distances ranging from 3 to 10 miles. So what can we eliminate here? A, 1,000 yards, and C, 4,000 feet. That makes no sense. If you go by, now just like the last 2 problems we did, there's such a thing as having too many and not enough. You're going from 3 to 10 miles. So do you think we should have 1 mile or 3 miles? 1 mile, because 10 is, it's more than 3 markings, because you'd have 3, 6, 9, but you wouldn't be able to show a more accurate representation, so you would have to use D, which is 1 mile. Give this a try. Bring it up. On this problem, let's eliminate stuff that we can knock out of there. We have a slope of 5, which is 5 over 1. For your x-axis, what should your units be for that? Just 1. 1 would be sufficient. So for the x-axis, you only have 2 choices for that, which means these are gone. Now we're going up to 5. Would it be a better representation to go up by 2s, 2, 4, 6, 8, or just by 1, 2, 3, 4, 5? 1, 2, 3, 4, 5, which means the answer is B. How many yards are in a mile? A, B, C, or D? Bruton?
D.
No, it's not D. And Clyburn. C is right. It should be 1,760 yards. Number 2, how many feet are in a mile? Yes. B, 5,280. That is right. And 3, how many inches are in a yard? Yes. No. If you're going to miss it, you might as well have a smile while you're doing it. Anderson. D, yes, 36 inches. 36 inches in a yard. Now we can go on to the new objective. This one is going to be reason quantitatively and use units to solve problems. Define appropriate quantities for the purpose of descriptive modeling. These are very good questions, like what you would see on an end-of-course exam from the Common Core. Example 3. Kenny has a jar full of coins he's been saving, just like he's been doing every year, which would provide Kenny with the most accurate idea of the amount of money he has in the jar. Counting the number of coins, weighing the jar, measuring the volume of the jar, setting up a proportion between the height of the jar and the amount that last year's height yielded. The key sentence in here is which would provide Kenny with the most accurate idea. An idea is another way of saying what? Starts with a G. Guess. So that eliminates what answer? It eliminates A. Now, is there anything in the problem that says something about the weight of the jar? No. Does it say how big the jar is? So in the jar, when it talks about the height of the jar, it's not referring to the real height of the jar. It's the height at which the coins make it up to. So you could do a proportion from the height of the jar before and then the height of the jar now, and he would know the amount of money from before, and he could have a good idea of what it's going to be now. So the right answer should be D. Example 4. In December, Phineas is trying to predict the cost of gasoline in his hometown for the summer. Which will give him the most accurate prediction? A, find the cost at every station in a 3-block radius. B, finding the cost on Memorial Day for the past 15 years. C, finding the percent increase between regular and high octane. D, asking the gas station attendant. How many think it's A? 1. How many think it's B? How many think it's C? 1, 2, 3, 4, 5, 6, 7. How many think it's D? 0. And then some did not vote. Alright, so we'll go 2 for A. Now, it's in December. He's trying to predict the cost of gasoline. If he goes to a 3-block radius, that's going to tell him the amount, or maybe an accurate guess of the price of gas in a 3-block radius in his town. But does A say anything about what time? No. So it's gone. And for B, finding the cost on Memorial Day for the past 15 years. What month is Memorial Day in? Nope. Nope. May. Memorial Day is in May. What season comes after May? Season. What season? Summer. Right. And what's he trying to predict this for?
Winter.
No, you're in December now, and he's trying to predict it for the summer. So finding the percent increase between regular and high octane is not going to give him anything. It's just gasoline in general. This says nothing about high octane and regular. And asking the gas station attendant will give you information about how many gas stations.
What? I thought you had
Asking the gas station attendant will give you information about how many gas stations.
1.
1. So the answer should be B. There are 2 pages of these problems for homework, 5 on each page. Here is page 1 if anybody wants to take a picture.